All right, today we're going to pull back the curtain on the AI revolution. We're going right to the engine that powers, well, pretty much everything these days, from the voice assistant in your pocket to computers that can dream up incredible art. We're talking about deep learning. And it turns out this whole massive field really boils down to one simple but incredibly powerful idea.
I mean, think about it. We're living in this age of what feels like digital magic, right? Our phones can listen to us talk and just type it out perfectly. Apps can look at a flower in your garden and tell you exactly what it is. You can point your camera at a sign in another language and see it translated instantly. For so long, these were things only humans could do, but not anymore.
So you gotta ask, how does this all actually work, right? How can a hunk of silicone and code do these things that feel so intuitive? Is it actually thinking? Does it understand what a cat is? Or is there something else going on entirely? Well, as cool as it would be, the answer isn't magic. It's a specific approach to artificial intelligence called deep learning. And at the very heart of it is one single idea that completely changed the game. See, the big secret here, the real genius of it, wasn't trying to teach a computer a giant list of rules for every single situation. I mean, that's impossible. No, the breakthrough was figuring out how to teach it to learn for itself. And it does this using this incredibly powerful concept called learning representations. Now, to really get why this is such a huge deal, you have to look at how we used to do things. It was called feature engineering, and it was frankly a total nightmare. You'd have a human expert literally sit down and hand code all the important features for the machine. Like, okay, computer, a cat's ear has this specific curve, or this is a hard rule for French grammar. It was tedious, it was brittle. If anything changed, the whole thing broke. Deep learning, it just flips the whole thing on its head. It figures out the important features all on its own, just by looking at the raw data. Okay, here's a super simple way to picture this. Imagine you've got these two groups of dots, the gray ones and the teal ones, all jumbled up together. Now, your only tool to separate them is a single straight line. Go ahead, try. It's impossible, right? There's just no way to draw one line that neatly divides them. As the problem is currently represented, it's unsolvable with our simple tool. But what if we could just change our perspective? What if we could transform the data itself, find a new way to look at it, a new representation? Suddenly, look at that. The problem becomes ridiculously easy, a piece of cake. All the gray dots are on one side, all the teal dots are on the other. And that right there is the core idea of deep learning. It's all about finding clever transformations that make impossible problems simple. So here's the key takeaway, the official definition, if you will. Deep learning is basically an automatic search process. The machine isn't just memorizing stuff. It's actively searching for the best possible data transformations to solve a problem. And how does it know if it's getting warmer? It gets a feedback signal, basically a score that tells it how well it's doing, pushing it in the right direction. And this whole learning process, it's actually a really simple loop. It's beautiful. First, the model makes a guess. Then it measures its error. How wrong was that guess? Step 3. Based on that error, it makes a tiny, tiny adjustment to its internal settings to do a little bit better next time. And step 4, it repeats and repeats and repeats millions, sometimes billions of times, each time getting just a little bit smarter. Okay, so how are these learning machines actually built? Well, what's so cool about it is that they're not these single monolithic things. They're actually built from really simple modular parts. You can almost think of them like digital Legos. These Lego bricks are what we call layers, and each individual layer does one of those simple data transformations, kind of like that perspective shift we just saw with the dots. But when you start stacking these layers one on top of the other, that's when the magic happens. The model can learn incredibly complex, layered ways of understanding data. And that's all the deep in deep learning means, by the way. It just means you're stacking up a lot of layers. And just like you wouldn't use the same Lego bricks to build a car that you'd use to build a castle, you use different types of layers, different architectures for different kinds of data. So for something simple like spreadsheet data, you'd use what are called densely connected networks. If you're working with images, you'll use 2D convenets, which are amazing at finding visual patterns like edges and textures. And for anything that comes in a sequence, like text or audio, you'll use things like transformers and recurrent networks, which are specifically designed to get the importance of order and context. Okay, so up to this point, we've been talking about AI that can recognize and classify things that already exist. But what happens if we flip that whole process around? What if, instead of just understanding data, we could use that knowledge to create something totally new? And this is where things get really, really wild. Can a model that's learned what a cat looks like by seeing thousands of photos, can it actually generate a picture of a brand new cat, one that has never existed in the real world? And the answer is a huge, resounding yes. Because once a model learns the underlying statistical structure, the rules of what makes a handwritten number look like a number, it can then use that knowledge to dream up completely new examples. I want to be clear, none of the digits you're looking at right now are copies. They are all 100% artificial, generated from scratch by the model. And this exact same idea applies to text too. A model can read, say, tens of thousands of movie reviews. It doesn't understand them like we do, but it learns the statistical patterns, which words tend to follow other words, the general tone, the sentence structures. Then you can just give it a starting word and say go, and it will sample from its learned knowledge, word by word, to write a completely original movie review that sounds totally plausible. So this all brings us to the future, to the next frontier. As these models get more and more powerful, they're not just technical tools anymore. They start to raise these really deep questions about what intelligence even is, what creativity means, and what our place is going to be alongside them. I absolutely love this quote from the composer Yannis Xenakis. He imagined a future where automation wouldn't get rid of the artist. Instead, it would turn them into a pilot, someone who supervises the controls of a cosmic vessel sailing in the space of sound. And I think that's such a beautiful way to frame it. Our relationship with AI doesn't have to be a competition. It can be a collaboration where we're the ones steering these unbelievable tools into brand new, uncharted creative territory. And that really leaves us with a big question to chew on. Deep learning models are absolute masters at finding patterns, at finding the cleverest possible shortcuts to solve a problem. But are we actually teaching them to think? Are they getting a real, flexible understanding of the world the way we do? Or are they just getting really, really good at creating a convincing imitation of intelligence? That right there is the question that's going to define the entire next chapter of AI.